All right, everyone. Assalamu alaikum. Let's begin. We were doing quadratics, and we were done with all the concepts that we had to cover in this topic. So, what have we done in this topic? Let me just quickly review all of that, as in just let you know what we've done. The list of concepts that we've done. So we started with this: how to solve quadratic equations using factorization and using the quadratic formula. We talked about what these solutions of a quadratic equation represent graphically. They represent the x-intercepts on the graph of this function. We talked about shapes of quadratic graphs, U shape, N shape, and some properties related to that. We talked about how to find turning point of a quadratic function. There were different methods that we did for that: minus p over 2a, completing the square. There were different methods that we did for completing the square as well. And then we talked about how to find the turning point from the computed square form. We talked about the special case of completing square, where they sometimes ask you to convert it to a form that does not have the coefficient of x as 1 inside. You have some other number inside multiplying with x. So we discussed how to deal with problems like these. That's what we did in the beginning. Then we talked about these different cases for discriminant, how we have these cases for discriminant, b square minus 4ac, that when b square minus 4ac is greater than 0, you get two distinct real roots. Graphically, that means that the line and the curve, they intersect at two points. We talked about b square, what happens when b square minus 4ac is equal to 0. We get two real and equal solutions. And graphically, that means that the line is a tangent to the curve. That means it only touches the curve at one point. And then b square minus 4ac less than 0. That means there are no real roots. Graphically, it means the line is the line and the curve, they do not meet each other. And then there was this case as well, where the first two cases were kind of combined. B square minus 4ac greater than or equal to 0. When does that happen? When they say that there are real roots, but they do not specify how many roots they're going to be. It could be one root, two roots. In this case, you have b square minus 4ac greater than or equal to 0. And graphically, that means the line meets the curve without specifying at how many points, right? So this is what we did related to discriminant. Then we did some practice questions. This was the next major concept, that was how to solve quadratic inequalities, right? So we talked about how to do this. We treat those inequalities as equations, first of all, to find the x-intercepts, and then we look at the graph to see which region or regions on the graph satisfy the given inequality. If it's greater than 0, we look for the region that's above the x-axis. If it's less than 0, we look for the region that's below the x-axis, and write down the values of the ranges of x, the intervals of x based on that. That's what we did. We did a number of examples in this. And then lastly, we talked about these hidden quadratic equations or disguised quadratic equations. What do you do in such equations? Basically, you have some higher power of x or some other power of x apart from 2. They're not actually quadratic equations, but you can convert them to quadratic equation. How do you figure out if you can do that? The powers need to be in this ratio, 2:1. If the powers are in this ratio, 2:1, what you do is you substitute the smaller power with another letter, and then it becomes a quadratic equation. You solve it like a quadratic equation. At the end, you put that substitution back to find the values of the variable that you're given in the question. This is what we did. Did some examples in this, and that's it. So these are all the concepts that we've done in quadratics. Now today will most likely be the last session that we spend on this, hopefully. Then tomorrow we can start our next topic. So you can let me know now if you have any particular questions from the worksheet or from the questions that I assigned apart from the worksheet. So these are 4 questions that I asked you to do. I pasted them in the OneNote notebook, and I expected you to attempt them for this class. So I would ideally want to discuss some of these questions today. That's one thing that I want to do. And you can also let me know if there are any other problems from the worksheet or from recent papers that you have. We could also discuss them. So I'll start with your questions first. You can let me know first if you have any problems, especially out of these 4 questions first. And then if there are any other questions, you can also let me know about them. Yes.
Sir, I had a problem with question 2 from the 4 assigned questions you gave us.
Okay. So just a reminder, if you want to send a message, please send messages to this account which says message here so that I can see that on my other device. Otherwise, I'll have to keep switching windows if you message on the other account. Okay. Are you talking about this one, Hazim?
Yes, sir.
Okay, let's have a look at this. This is an important question because this is something that has come up multiple times in recent papers, and you would not find such questions in older papers. So this is an important one because you don't find such a question in the worksheet that I've given you. So that's why I assigned this separately, because this is a good one. Okay, so it says the equation of a curve is y equals 2x squared plus m into 2x plus 1. That's the equation of a curve where m is a constant. And the equation of a line is y equals 2x plus 4. So we have the equation of a curve given and the equation of a line given. Now the question says, show that for all values of m, the line intersects the curve at 2 distinct points. If the line and the curve intersect at 2 distinct points, what does that mean? This means b squared minus 4ac is supposed to be greater than 0, right? But this is not given in the question. It's not given in the question. They're basically asking you to show this. They're asking you to show that the line and the curve intersect at 2 distinct points, no matter what the value of m is. Okay. Now, how is it different from the questions that we've done before? So let me show you, for instance, one question that we might have done before. And this is different. Tangent to the curve. Let me find a question that tells us. Yeah, this one. Question number 5 that we did from the worksheet. It says, find the set of values of m. So it says, find the set of values of m for which the line intersects the curve at 2 distinct points. Now, in this question, we are given that the curve and the line, they intersect at 2 points. So that means we can start from this. We can start from b squared minus 4ac greater than 0, and then use that to find this set of values of m that they ask us to find. So in this case, they ask us to find the values of a constant, given that the line and the curve, they intersect at 2 points. But in this question that we just started, what they're saying is, like, in this question, what they're saying is, show that for all values of m, the line intersects the curve at 2 distinct points. They're not asking you for some specific values of m or the set of values of m. They're not asking you to find the values of m here. They're asking you to show that no matter what the value of m is, the line and the curve, they intersect at 2 distinct points. Now, this is the key difference between the two questions. We're not looking for values of m here. We need to show that the line intersects the curve at 2 points. That means we need to show that b squared minus 4ac is greater than 0, no matter what the value of m is. That's what we need to show. Now, how are we going to approach this? We have a curve y equals 2x squared plus m into 2x plus 1. and we have a line which is y equals 6x plus 4. How do we start? We equate the two functions, right? Because again, we're talking about points of intersection, right? We're talking about the line intersecting the curve. How do we find points of intersection in the first place? We equate the functions, right? So that's what we do. We equate the two functions, and that gives us 2x squared plus m into 2x plus 1, that equals 6x plus 4. Okay, so we equate the two functions, we get something like this. Now we convert it to the standard form. What's the standard form? Ax squared plus bx plus c equal to 0. So all the terms on one side, only 0 on the other side. All right, so let's take all terms to one side and simplify this. This gives us 2x squared plus 2mx plus m minus 6x minus 4 equals 0. And now we could simplify this to get 2x squared plus, we have two x terms. This is an x term, this is another x term. So what's the coefficient of x then? We could take x common from these two terms, and that gives us 2m minus 6 whole multiplied by x. Okay, I could just change the order in the previous step. I could say this is 2mx minus 6x plus m minus 4. All right, that's what it looks like. So these are the coefficients of, write them together, 2m minus 6 whole multiplied by x. And then we have the constant term. The constant term is m minus 4. This is the equation. Okay. Now, using this, what we want to do is we want to find b square minus 4ac. So square minus 4ac. B square minus 4ac. Let's see what that is going to be. Now, for that, it's often a good practice to write the values of a, b, and c first. What's a? In place of a, we've got 2. In place of b, we have 2m minus 6. And in place of c, we have m minus 4. So what's b square minus 4ac going to be? It's 2m minus 6 whole squared minus 4 into 2 into m minus 4. This is b square minus 4ac. Now you are not going to say that this is greater than 0. Okay, do not write this at the end, greater than 0. It's not given. They are asking you to show this. You have to show that this expression is greater than 0. Okay, so you're not going to start from that. You're going to look at this. You're going to look at this expression and prove that this is greater than 0. Okay, how do we do that now? Let's simplify this. This is a quadratic expression. Let's simplify b square minus 4ac and see what we get from this. 2m, this is a minus b whole squared, right? 2m whole squared, that's 4m squared. Minus 2 into 2m into 6, that is going to give you 24m. Plus 6 squared, that is 36. Minus 8 into m, that's minus 8m. Minus 8 into minus 4, that is plus 32. Let's simplify this. That gives us 4m squared minus 24 minus 8, which is 32m plus 68. This is your b square minus 4ac. Now what we need to do is we need to show that this is always greater than 0. This is what we need to show. Remember what the question says? Show that for all values of m. For all values of m, the line intersects the curve at 2 distinct points. That means show that for all values of m, this b square minus 4ac is greater than 0. How do we show that? You can try inputting values of m here, maybe 1, maybe m equals minus 5, m equals minus 100, m equals 90. No matter what value of m you input here, you would see that the result is always positive. Okay, this is always going to be greater than 0. But this is not the correct method to prove this, because you can't do this for every single possible value of m, right? There are infinitely many possible values that you can input. You can't possibly show that for each value. So you need to show that generally this expression always has to be positive. Now, how do we prove that? Let's look at this expression. what type of an expression is this? This is a quadratic expression, right? M squared. If you were to draw a sketch or sketch this expression on a graph, how would it look like? It's a quadratic expression, right? With the coefficient of m squared, the coefficient of the quadratic term positive, it would actually look like this, right? This thing, if you were to plot this, it would be a U-shaped curve. Remember what we are plotting here? We're plotting 4m squared minus 32m plus 68. What we can do now is we can find what the minimum point of b square minus 4ac is. If that minimum point is positive, we can say that this whole thing is always going to be positive. If the minimum point is positive, then the whole thing has to be positive, right? Now you could do this using minus b over 2a if you want. You can find the minimum point and then say that the minimum point of b square minus 4ac is greater than 0. Or you could just complete the square. You can do it either way. Let's say if you were to complete the square for this, how would that go up? How would that process go up? Like in this case, we would take 4 common first of all. And that leaves us with m squared minus 8m inside. We leave some space, and then we have 68 over 4, which is 17. Add 4 squared and subtract 4 squared to complete the square. These first 3 terms are going to give you a perfect square. So it looks like this. 4 into m minus 4 whole squared minus 16 plus 17. And that gives you 4 into m minus 4 whole square plus 1. And you have 4 into m minus 4 whole squared plus 4. So what's the turning point then? The turning point here is 4 and 4. Can you see what the minimum point of minimum value of b square minus 4ac is now? Remember, this graph is for b square minus 4ac. It's not the graph of the original function, remember. It's not the graph of this curve. It's not. We are basically sketching b square minus 4ac, this thing. When we sketch that, we get that the turning point of this expression is 4, 4. What does that say about the minimum value? The y-coordinate of the turning point is 4. So that means this function, this expression has a minimum value of 4. It cannot be below 4. No matter what value of m you input here, the least value you can get is 4. You can argue that from this expression as well, because you see, you've got a positive number and a square. This thing can never be negative. So this has to be greater than or equal to 0. Then you have plus 4. So that means the whole thing has to be greater than or equal to 4. Or you could do that from this curve as well. You could say the minimum point is 4. So what do you say now? You say the minimum value of b square minus 4ac is 4, right? The minimum value of this is 4. This is what we're talking about, the y-coordinate of the turning point. If the minimum value of b square minus 4ac is 4, what does that mean? This means that b square minus 4ac is always greater than 0. And that means the line and the curve, they intersect at 2 points. This is what we needed to show, that the line and the curve, they intersect at 2 points, no matter what the value of m is. You can input any value of m here. The result is always going to be 4 or greater than 4. So b square minus 4ac is always positive. And that means we have 2 distinct solutions always. Is that okay? So there are some questions in which they ask you to show that there are two roots or one root or no roots. How do you do that? You don't start by writing this greater than 0 or equal to 0 or less than 0. You just find b square minus 4ac. Just find this expression. And then you find the turning point of that expression. Usually it's a quadratic expression. So you find the minimum point or the maximum point of that expression to figure out whether b square minus 4ac is greater than 0 or equal to 0 or less than 0, whatever they're asked for in the question. Does that make sense? Let me know if you have any questions on this. It is slightly confusing at first because you're not used to doing this. You're used to starting with an inequality or an equation in the beginning, but it's not like that. You have to prove that. So let me know if there are any confusions, any questions. Any questions on this? Can I have raise of hands from everyone who understands this? Arham, Aisha, Naima, Hira, do you have any questions? Any confusion? No questions? Okay, good. Let's try another one very similar to this, just to make sure that we understand this very well. So this was another one that I asked you to do. In fact, in this case, they ask you for the set of values. Okay, let's do this as well, so that you understand the difference between the two again. So it says y equals x plus 1 and y equals x squared plus bx plus 5. It says find the set of values of the constant b for which the line meets the curve. So now you have to find the set of values of b for which the line meets the curve. You don't have to show anything. It says the line meets the curve. What does that say about b square minus 4ac? What should that be? The line meets the curve.
It should be equal to 0.
It should be equal to 0.
No, greater than or equal to.
Greater than or equal to 0. Because if it says the line meets the curve, it might be meeting at 1 point or at 2 points. Both possibilities are there, right? So we say it's greater than or equal to 0. Okay. And then it's a standard question. You just equate the two. X plus 1 equals x squared plus bx plus 5. Take all terms to one side. That gives you x squared plus bx minus x plus 5 minus 4. 5 minus 1, which is 4. What's the coefficient of x? The coefficient of x is b minus 1. We take x common outside. We have b minus 1 left there as the coefficient of x. And then you say, let's put b squared minus 4ac greater than or equal to 0. In place of b, we've got b minus 1. So let me actually write those down here first. In place of a, we have 1. In place of b, we have b minus 1. In place of c, we have 4. So we get b minus 1 whole squared. That is that minus 4 into 1 into 4. That's greater than or equal to 0. Let's simplify this. This gives us b squared minus 2b plus 1 minus 16 greater than or equal to 0. B squared minus 2b minus 15 greater than or equal to 0. And now we need to solve this inequality. How do we solve inequalities like these? It's a quadratic inequality. We say, let's treat this as an equation. Let's treat this as an equation first. And then we would basically look at the part on the graph that is above the x-axis, right? So what does the graph of this function look like? It's a U-shaped graph because the coefficient of b square is positive. It's a U-shaped graph. So what we're looking for right now is these x-intercepts of this graph, right? That's what we want to start from. x-intercepts. Now, how do we find those x-intercepts? By treating this as an equation. Can we factorize this? Well, we can. It becomes b squared minus 5b plus 3b minus 15 equal to 0. We get two factors from this, b minus 5 and b plus 3. So that means b is either equal to 5 or b is equal to minus 3. So on the graph now, we have two x-intercepts. One is minus 3 and the other is 5. These are the two x-intercepts or the horizontal axis intercepts that we get here. Now, what's the inequality sign? It's greater than or equal to 0. So we're looking for the region on the graph where the graph is above the x-axis, right? So that's this region or this region. So what are the corresponding values for x then? Towards left of minus 3 and towards right of 5. These are the possible values of b. In fact, b is the variable here, not x. So what do we say then? We say the final answers are b less than or equal to minus 3 and b greater than or equal to 5. We put the equal to sign as well because the inequality has it. So we say b is less than or equal to negative 3 and b is greater than or equal to 5. Yes, that's exactly what we get. Okay, these are the final answers that we have. We write these as separate inequalities because we have two separate regions, right? You cannot write it together. If it was the region in the middle, if it was a less than equal to sign, for instance, the region in the middle would be written as a single inequality because that's a single region. Okay, but the region on the side, there are two regions, so we write them separately. All right, I hope that makes sense. Any quick questions on this? No? Let's move on to the next one then. If there are no problems, let's move on to the next one. This was another one. This is not that tricky, I think. Let me look at this one. Yeah, let's try this one. A curve has equation y equals 2x squared minus 3x plus 1, and a line has equation y equals kx plus k squared. Y equals 2x squared minus 3x plus 1, and the line is y equals kx plus k squared. So we have a curve and we have a line. It says show that for all values of k, the curve and the line meet. Again, they're not asking you for values of k here. They're asking you to show that the curve and the line meet. What does that mean? The curve and the line meet. That means b squared minus 4ac is greater than or equal to 0. But that's not given. You have to show this. You have to show that b squared minus 4ac is greater than or equal to 0. Okay? So again, how do we approach this? We create the two functions, first of all. That's how we start, as usual. On the right side, we have kx plus k squared. Take everything to the left side, write the like terms together. So we have 2x squared minus 3x minus kx plus 1 minus k squared. That equals 0. 2x squared, what's the coefficient of x? We can take x common. That leaves us with minus into 3 plus k times x. And then we have plus 1 minus k squared. A is 2, b is minus into 3 plus k, and c is 1 minus k squared. Okay, I've seen a message. So after this, we'll have a look at them. Okay. So what do you have to do now? Find b squared minus 4ac and prove that that is greater than or equal to 0. Okay. Let's try this now. B squared minus 4ac. We first have to find this. We cannot put this greater than or equal to 0. That would be wrong, okay? So we have minus into 3 plus k whole squared minus 4 into 2 into 1 minus k squared. Right? Now, there's a minus sign here. And we have a square outside. So this minus sign can get eliminated. And we have 3 plus k whole squared minus 8 into 1, that's minus 8. Minus 8 into minus k squared, that's plus 8k squared. That is b square minus 4ac. And now we need to prove that this is greater than or equal to 0. So we approach it the same way that we did in that earlier example where we had to show something like this as well. Let's simplify this first. This is a plus b whole squared. So it becomes 9 plus 2 into 3 into k. That's 6k plus k squared minus 8 plus 8k squared. And what does that give us? That's 9k squared plus 6k plus 1. That is b square minus 4ac. And again, now we need to prove that this is greater than or equal to 0. How do we do that? Again, we think of this function. This is a quadratic expression, right? B square minus 4ac. If you were to draw this, it will look like this: 9k squared plus 6k plus 1. We're talking about discriminant. This is the curve that we can represent the discriminant by, a U-shaped graph like this. Okay. Now, we have to show that this graph is greater than or equal to 0. Again, we can find the turning point of this. We could do that using completing square, or we could do that using minus b over 2a. If the turning point is 0 or above, we could say it's greater than or equal to 0. Okay, so you can find the turning point again. You can use any method that you want. If you were to complete the square here as well, we could take 9 common outside. It will be slightly more complicated because we'll have fractions inside now. But let's try this. K squared plus 6 over 9. 6k over 9, what is that going to become? 2k over 3, right? When simplified. And you leave some space. And then we have plus 1 over 9. So what I've done is I've taken 9 common outside. Okay, that leaves me with k squared plus 2k over 3 plus 1 over 9. And now I have to add and subtract square of half of 2 over 3. What's half of 2 over 3? It'll be 1 over 3, right? So plus 1 over 3 squared minus 1 over 3 squared. Now these 3 terms give us a perfect square, k plus 1 over 3. So what do we get from this? 9 into x plus, in fact, k, not x, this is k. K plus 1 over 3 whole squared minus 1 over 9 plus 1 over 9. Now this becomes 0, and outside we have 9 into k plus 1 over 3 whole squared. This is what b square minus 4ac is. So what's the turning point now? Outside we have nothing, right? It's 0 because this gets cancelled. We just have 0 outside. So what are the coordinates of this turning point then? These coordinates are going to be minus 1 over 3, right? We have to flip the sign, and 0. So what does that mean about the minimum point of b square minus 4ac? The minimum point of b square minus 4ac is therefore 0. We could also argue that from this expression, we have a positive number and a square. We know a square is always greater than or equal to 0, right? So that's another way to think about this. What you say after this point is, you say minimum value of b square minus 4ac is 0. What that means is b square minus 4ac therefore is greater than or equal to 0. And that's what we have to show. We say the line and the curve, they meet each other. We don't know at how many points. It could be 1 point if it's equal to, it could be more than 1 point if it's greater than, but they meet each other. The line and the curve, they meet each other. That is what we had to show. So when there are show questions like that, show that question like this, we start from b square minus 4ac, we simplify that, and we could complete the square to figure out what the turning point is, what the minimum point or maximum point of b square minus 4ac is, and then show whatever is required based on that. Any question on this? Any question on this? No? All right, the second part says, state the value of k for which the line is a tangent to the curve and find the coordinates of the point where the line touches the curve. Now, if the line is a tangent to the curve, what does that mean? That means b square minus 4ac should be equal to 0. Do we already have b square minus 4ac? We have found b square minus 4ac in this form here already. What was that? That's 9 into k plus 1 over 3 whole squared equal to 0. So we put that equal to 0 and find the value of k from this. 9 is going to get cancelled here, and we would just be left with k plus 1 over 3 whole squared equal to 0. We could just remove the square because we have 0 on the other side, right? So we could say square root of this. That leaves us with k plus 1 over 3 equal to 0. And that gives us k equal to minus 1 over 3. So that's what the value of k should be, minus 1 over 3, if the line is a tangent to the curve. Okay, that's what the second part says. State the value of k for which the line is a tangent to the curve. So k should be minus 1 over 3. Okay, so now we know k is minus 1 over 3. We need to find the coordinates of the point where the line touches the curve. Well, we already have the equation of the curve. The equation of the curve is y equals 2x squared minus 3x plus 1. And equation of the line was kx minus k squared plus k squared. Now we know the value of k, so this becomes y equals minus 1 over 3x plus minus 1 over 3 whole squared. So it becomes minus 1 over 3x plus 1 over 9. We have the equation of a curve. We have the equation of a line. We have to find the point where the line touches the curve. How do we do that? We solve these two simultaneously. I expect you to be able to do that now. We just equate them, right? 2x squared minus 3x plus 1 equal to minus 1 over 3x plus 1 over 9. We'll find some value of x from this, put that back in the linear equation or in the quadratic equation, whichever you prefer. You'll get the value of y corresponding to this as well. So you can find the values of x and y from this. Okay, just solve them simultaneously. That's what you were looking for here. Is that okay? I think you should be able to do it after this point. We can move on to the next one. Right? I would appreciate some response.
Yes, sir.
No questions then?
No, sir.
Okay, good. Now, let me just give you a hint about this one as well. It's not difficult, but there's just one thing that's slightly different from what we are used to doing before. So one equation is, one line is this, 4y equals x plus c, and there is a curve that is y square equals x plus 3. It says find the value of c such that the line is a tangent to the curve. Okay, so that means b square minus 4ac is equal to 0. Now, generally what we are used to doing is that we make y the subject in both the equations, right? And then we equate the right hand side, right? That's what we are used to doing, right? Make y the subject and then equate the two. But now the problem is we have y squared here, okay? So that's not recommended that you take square root here, because when you take square root, you get plus minus, you'll get something like this. So you should not be doing this, okay? One possibility here is that you make x the subject, because x does not have any power here. So a quick way of doing this could be that you make x the subject, x equals 4y minus c, and from this x equals y square minus 3. And what you do is you equate these x's then. You get 4y minus c equals y square minus 3. This gives you a quadratic equation as well. Y squared minus 4y plus c minus 3 equals 0. And then you apply b square minus 4ac on this. You say b square minus 4ac is supposed to be equal to 0. That gives you minus 4 whole squared minus 4 into 1 into c minus 3 equal to 0. And you could get the value of c from this. That's one possibility. The other possibility is you could find y in terms of x from the first equation. So you could say y equals x plus c over 4, and then put this value of y here, and you could get an equation in terms of x from that. But please do not try taking square root of this to make it y equal plus minus square root of x plus 3. That would become too complicated because you'll have to consider two cases, one with plus sign, one with minus sign. So you should not be doing that here. So the reason why I thought this was necessary to clarify, because a lot of people are just used to always doing this, that they just learned this, okay, always make y the subject and then equate them. In this case, it's not recommended to make y the subject in both of them, because you'll have to take square root, and that will introduce plus minus, and that will be a bit complicated to do. Okay, so if there's some power of y, like in this case, you don't make y the subject in place. Instead, look at x instead. In this case, x does not have any power. So you can make x the subject and then equate those two things. Okay. Or the other possibility I showed you, you could use substitution like this, make y the subject in the first equation, put that in the second one, and you could do it like that as well. So both of them are going to give you the same result. In this case, if we were to solve this, we get 16 minus 4c plus 12 equals 0. 4c equals 28, and the value of c turns out to be 7. Okay, so that was just one point that I wanted to make clear. I hope that makes sense. The second part is not that difficult. You can try that as well. Okay, so these are some questions that I wanted to discuss because these are important as far as the recent papers are concerned. I hope these are all clear. Now let's quickly have a look at some of these questions that Ima sent to me on WhatsApp quickly. Okay, so there's one question from May, June 2022, paper 1, variant 1. Find the set of values of constant k for the dynamic equation. This intersects the circle at two distinct points. You haven't really done equation of circle yet, but you could still do it without that as well. Yeah, you can actually still do it. We will be doing the equation of circle at a later point, but this part is still doable. We will have a look at that. Okay. There's then May, June 2022, paper 1, 3, question number 11. The curve has this equation, find the values p and q in terms of m, the normal. Achha, the question number 4 that you posted, that's differentiation. So we can't do that right now. The second part is differentiation. The first part is coordinate geometry. That's not a quadratics question as such. Yeah, you have to solve a quadratic equation at some point. Yeah, that's all that is relevant to quadratics, but you need some other concepts for that as well. Actually, first part, yes. First part is quadratics. Second part is not. So first part, we can have a look at that quickly. Okay. November 14, this equation has no stationary points. For which y is a decreasing function of x. Yeah. The second question that you've posted, October, November 14, this is again differentiation. We can't do that at this point. All of this is differentiation. Okay, so without differentiation, you can't do it. We will be starting differentiation soon, by the way. So we should be able to do these questions after that. Okay, find the set of values of a for which the curve is equal to this and straight line meter two distinct points. That's pretty straightforward. Find the bonus points section of this and this. Okay, I think you mean the second part, the second question in the screenshot. Okay, now let's have a look at these questions quickly. They are not going to take too much time. We'll try to do all of them, the ones that we can do using the concepts that we have covered until now. Okay, let's start with this one. June 2022, paper 1, variant 1. Okay, so question number 9 from this. In the first part, you have the equation of a circle given. This is a coordinate geometry concept. They ask us to find the coordinates of the center of the circle and the radius, hence find the coordinates of the lowest point of the circle. Okay, so this requires coordinate geometry concepts. We are going to skip this part. Let's look at the second part. In the second part, they give us the equation of that circle. Okay, I'll have to write down the equation of that circle, in fact. Okay, copy this first. Just paste it here. All right, so we have this equation of a circle given. So that's the form of the equation of a circle. June 2022, paper 1-1, question number 9B. Okay, now using this equation, they ask us to find the set of values of the constant k for which this equation intersects the circle at two distinct points. Okay, now x squared plus y squared plus 6x minus 2y minus 26 equals 0. And y equals kx minus 5. Okay, now that's a good one because we just discussed why we cannot make y the subject because it has a power 2 here. We would have to take square root at some point. That will introduce plus minus. That's not a good idea. In this case, we can't even make x the subject because x also has a power 2. So we are not going to approach it the same way as before, as in we are not going to make y the subject in both equations or even x the subject in both equations. Instead, we're going to do simple substitution, right? How do we solve equations simultaneously? We could do substitution, right? So when we used to make the same variable the subject in both equations, that was also a particular kind of substitution. Now we do simple substitution like this, that we have y equals kx minus 5. All we have to do is just put this in the first equation. You put y equal to kx minus 5, right? Then the question says, find the set of values of the constant k for which the line with this equation intersects the circle at two distinct points. If it intersects the circle at two distinct points, that means b square minus 4ac is supposed to be greater than 0. So when you put y equals kx minus 5 here, you get a quadratic equation from that. And that's going to look like this: x squared plus kx minus 5 whole squared plus 6x minus 2 into kx minus 5 minus 26 equals 0. You simplify this now to get x squared a minus b whole squared. That's going to be k squared x squared minus 2 into kx into 5. That is minus 10 kx. 5 squared is 25 plus 6x minus 2kx plus 10 minus 26 equals 0. Now we have two x squared terms, and we have, so let me actually shade them. These are two x squared terms. Then we have this x term, and this x term. And then the rest are constants. Let's write them together. X squared plus k squared x squared. You could actually just take x squared common here to get 1 plus k squared as the coefficient of x squared, right? And then what's the coefficient of x? Let's simplify that first. We have 6x, and then this is minus 10k and minus 2k. That is going to be minus 12kx. 25 plus 10 is 35. 35 minus 26 is going to be 9. Now let's take x common from the x terms as well. That is going to give us 6 minus 12k whole multiplied by x plus 9 equals 0. So now we have this in the standard form, ax squared plus bx plus c equals 0. All we have to do now is put b squared minus 4ac greater than 0. Okay. What do we have in place of a? In place of a, we have 1 plus k squared. In place of b, we have 6 minus 12k. And in place of c, we have 9. So we can say b squared minus 4ac should be greater than 0. Right? We use this. And just input values now. 6 minus 12k whole squared minus 4 into 1 plus k squared into 9 greater than 0. That gives you 36 minus 2 into 6 into 12. That's minus 144k plus 12 squared is 144k squared minus 4 minus 4k squared. No, I'm sorry. There's 9 there as well. Okay, so 4 into 9 is 36. That's minus 36. And then 36 into k squared, that should be minus 36k squared greater than 0. Let's simplify this now. 144 minus 36, that gives us 108k squared minus 144k. 36 and 36 get cancelled. And this is greater than 0. We could simplify this, because 108 is 36 times 3 and 144 is 36 times 4. So this can be simplified to 3k squared minus 4k greater than 0. This is a quadratic inequality that you need to solve now, right? How do you solve quadratic inequalities? You treat them as an equation. 3k squared minus 4k equals 0. You take k common. That leaves you with 3k minus 4 inside. That means either k equals 0 or k equals 4 over 3. It's a quadratic function. What's the shape of this quadratic function? U shape like this. Okay. What we have done is we have found the two intercepts with this horizontal axis. The left one is going to be 0 and this one is going to be 4 over 3. The sign is greater than, so it's either this region or this region. We say the set of values of k are k less than 0 or k greater than 4 over 3, because it's either the region on the left side or on the right side. These are the set of values of k that you get from this. Is that okay? So you just treat like a normal quadratic equation, put b squared minus 4ac greater than 0, and that gives the result. Any problem with this?
Sir?
Yeah.
Sir, हम इसको substitute क्यों करेंगे y square के अंदर?
They're talking about there being two intersection points, two distinct. Okay, so those of you who don't understand Urdu. So the question is, why are we substituting y equals kx minus 5 in this equation, right? Why are we doing this? Well, that's exactly what we've been doing throughout for all questions. For example, in this case, we had to find the two values of m in the second part, for which the line is a tangent to the curve. We had a curve and we had a line, right? We said the line is a tangent to the curve. That means there's only one point where the line and the curve meet each other. So we are basically talking about the point of intersection, the point where the line and the curve are equal to each other. So what did we used to do here? We used to make y the subject in both of them. In this case, they were already the subject. That's what we used to do earlier. And then we would equate both of them. We equate both of them. It's basically substitution. We are saying y equals 4x squared, y equals x squared minus 4x plus 5. And we put this in the second equation. That's exactly what we're doing here as well. In place of this y, we're inputting x squared minus 4x plus 5. So when we used to equate the two functions like this, we were actually doing substitution there, because we were putting one y equal to the other y. So you could think of it this way as well, that we have y equals mx minus 2x, mx minus 2m here. We're inputting mx minus 2m here in the other equation, and that's substitution. Now, in this case, we used to say that we're equating both of them because in both of them we had the same subject, so it was easier to think of it this way, that we just equate the two functions. But in actual, it was substitution as well. Now, when we have something like this, we can't have the same variable, the subject, in both equations. In the one equation, we have y as the subject. We can't make y the subject in this. Even if we could, we can, but in that case, we would have a square root and then a plus minus. That will make things complicated. So we say, let's do substitution like this instead. We have y equals kx minus 5 here. We put this in the other equation as it is. So rather than having the same variable as the subject first, we just do substitution directly. So we were doing substitution earlier as well. It was just another way of looking at it. This is another way of looking at that same substitution. So the starting point of such questions always has to be that we want to start the process of solving those two functions simultaneously. That's what we used to do earlier as well, and we're doing the same here as well. We're just substituting to start solving them simultaneously, because that's how you find points of intersection. Does that make sense, or does that confuse you more?
No. Okay, sir.
Okay. Is this clear to everyone? So when it's not possible to make the same variable the subject in both functions, you do substitution like this. Make one variable the subject in one of them, in which you don't have any square terms or anything. Put that in the other equation like this. Okay. All right. So this was one question. Then you have May, June 2022, paper 1-3. Question number 11. Okay, so we can only do part 1 of this for now, because part 2 involves differentiation. Let's quickly have a look at this. Okay, I'll try to be quick so we can end soon. June 2022, paper 1-3, question number 11. Okay, so the point P lies on the line with the equation this, y equals mx plus c, where m and c are positive constants. The curve has equation y equals minus m over x. There's a single point P on the curve such that the straight line is a tangent to the curve at P. So we have y equals minus m over x, and we have y equals mx plus c. So there's a point P on the curve such that the straight line is a tangent to the curve at P. Find the coordinates of P, giving the y coordinate in terms of m. Now, since the line is a tangent to the curve, what does that mean? B square minus 4ac should be equal to 0. So how do we start? We start by equating the two functions. We say minus m over x should equal mx plus c. We multiply x on the other side. That gives us minus m equals mx squared plus cx. Take everything to one side. Mx squared plus cx plus m equals 0. And now, since the line is a tangent to the curve, we say b square minus 4ac should be equal to 0. Right? What does that give us? C squared minus 4m into m equals 0. And that gives us c squared minus 4m squared equals 0. we get c squared equals m squared. Okay, so that's one equation that we have. Okay, c in terms of m. Now we leave it as it is and see what else we have. Right, we can't find the values of c and m from just one equation because it's two unknowns, only one equation. And it turns out the y coordinate that they're asking for here also has to be in terms of m. That means we can't really find the value of m. Okay, the answer has to be in terms of m. Now the second thing they ask for is find the coordinates of, okay, what's p? P is the point where the line and the curve, they meet each other, right? So it might be like this, that the curve looks something like this, maybe. M is positive and this is negative. Yeah, so it might be like this. That now it's not necessary for you to know the shape of the curve, but it might look something like this, for instance. Just think about it. Yeah, it might be like this. Let's say now the line would then be like this. This is the point that you're talking about, right? We have a curve and there is a line. This is where they meet each other. We're looking for point P. How do we find that point P? We just equate these two equations, right? We solve them simultaneously. So let's get back to those equations again. Y equals minus m over x and y equals mx plus c. We need to solve these two equations simultaneously. Okay, but now we want our answers in terms of m. That means we don't want c here. So what we can do is we can say, let's input c in terms of m instead. Okay, how can we do that? We have c square equal to 4m square. If we were to find the value of c, we could take square root on both sides. What does that give us? Square root of 4 is 2. Square root of m squared is m. Since we know m and c are both positive, so that's important now. Otherwise, whenever we take square root, remember we put plus minus. But since we know m and c both are positive, that means when we take square root here, we're not going to have a negative sign there. It's only going to be positive. So c equals 2m. Okay. So now we can say this line's equation therefore is y equals mx plus 2m. Okay. So these are two equations now. We just solve them simultaneously. Again, equate both of them. Minus m over x equals mx plus 2m. And that gives us minus m equals mx squared plus 2mx. Take everything to one side. That gives us mx squared plus 2mx plus m equal to 0. You have m in all the terms. You can just cancel that out by taking it common. So x squared plus 2x plus 1. M goes to the other side, gets divided by 0 because m cannot be 0, right? So we can divide by m on the other side. It gets cancelled. We have x squared plus 2x plus 1. We factorize this, and it's actually a perfect square, but let me just do the middle term breaking. This gives us x plus 1 into x plus 1, and that gives us x equals minus 1. So that's the x coordinate of the point P. How do you find the corresponding y coordinate? We put that in any one of these two equations. Let's put that here. And that gives us the corresponding y coordinate as well. That's minus m over minus 1, and y equals m. So what's the point P then? The point P is supposed to be minus 1 and m. Okay. Is that all right? So these are good questions. Thank you for bringing them up because they're slightly different from what we've done before. But the concepts are same. So as long as you understand the concepts, you should be able to figure this out. And this is the pattern in the recent papers, that they are not sticking to the same kind of questions. You'll find like 3-4 questions in every paper which are on a different pattern to what you've seen before. And they're focusing more on the fact that whether you understand the concepts well or not. So make sure that you understand all the concepts very well and not just, remember the steps that, okay, this is the first thing you do, this is the second thing you do in every question. Focus on the concepts. If your concepts are good, if your concepts are strong, you should be able to figure out if there's something slightly changed in the question, you'll be able to figure out what to do with that. So it's really important. Oh, anyway, any question on this? Any problem with this? Is this clear? Yes.
Yes, sir.
Yes, sir.
Okay. Now, the October-November 14 one, that's differentiation. So I'm not going to do that right now. Okay. The other one, May, June 17, paper 1-3. This is a short one. So just 3-4 minutes, hopefully, and we should be done. May, June 17. Okay, it's not here. May, June 17. Paper 1-3. Question number 3. Okay, let's have a look at this. Okay, so it's a quick one. All right, down here. June 17, paper 1-3, question number 3. Okay, so find the coordinates of the points of intersection of the curve y equals this and y equals this. We need to find the points of intersection, right? So we need to solve them simultaneously. Point of intersection is where the two curves are equal to each other, right? So how do we find them? We just do substitution or equate the two functions. Let's equate the two functions. We get x raised to power 2 over 3 minus 1. That equals x raised to power 1 over 3 plus 1. Let's take everything to one side, and that gives us x raised to power 2 over 3 minus x raised to power 1 over 3 minus 1 minus 1, that's minus 2 equal to 0. Now, remember what we said about equations like these. We don't really have a direct method of solving them. However, if you look at the powers, they are in the ratio 2:1, right? 2 over 3 ratio 1 over 3. What's that? That's 2:1. What do we do in problems like these? We say, let's suppose the smaller power is equal to a different variable. So let u equals x raised to power 1 over 3. We use substitution, and that converts this equation to a quadratic equation. U squared minus u minus 2 equals 0. So it's actually a hidden quadratic equation because the powers are in the ratio 2:1. What we do is we replace the smaller power with another letter. If u equals this, then that also means u squared is supposed to be x raised to power 2 over 3. So this equation converts to u squared minus u minus 2 equals 0. Now you can solve this equation. Can we factorize this? I think we can. U squared minus 2u plus u minus 2 equals 0. We can factorize this now. U into u minus 2 plus 1 into u minus 2. And we have two factors, u plus 1 into u minus 2 equals 0. And then you have u equals minus 1 or u equals 2. Okay, now you put that substitution back. U was supposed to be x raised to power 1 over 3. So we say x raised to power 1 over 3 is equal to minus 1 or x raised to power 1 over 3 equals 2. Now we need to get rid of this 1 over 3 power. What do? We basically take cube on both sides to get rid of the power 3. So we get one value of x, which is minus 1, because cube of minus 1 is minus 1 as well. And the other value of x is 2 cubed, which is 8. These are two values of x that we get. Now we need to find the corresponding y values. And it says points of intersection. So that confirms that you are going to get multiple points, right? Points. So that means multiple points, right? What about the y coordinate? You can put these values in any one of these two equations, whichever you want. Let's say the second one. That's probably easier to calculate. Y equals x raised to power 1 over 3 plus 1. Let's put these values there. Y equals x raised to power 1 over 3 plus 1. The first one becomes y equals minus 1 raised to power. In fact, we already have these values, minus 1 and 2. You could actually just input those as well, or you could do it again. That's your choice. This one gives us this. The other one gives us 8 raised to power 1 over 3 plus 1. So from the first one, we have minus 1. Cube root of minus 1 is also minus 1. So minus 1 plus 1. Y equals 0. And cube root of 8 is 2. So 2 plus 1. That gives us y equal to 3. So the 2 points that we're getting are -1, 0, and 8 and 3. Okay, these are the points of intersection that we were looking for. We just had to solve those two equations simultaneously, and it turns out they're actually it becomes hidden quadratic equation because the ratios are in the powers are in the ratio 2:1. We solve it as a quadratic, and then we find the values of x and y from that. Make sense? Any problem with this?
No, sir.
No? All right, great. So that's all that we wanted to do today. Aima, I hope that answers your question. Is that clear?
Yes, sir.
Okay, so tomorrow then we start our next topic. I still need to think about what we should be starting next because I want to sync it with paper 3 as well. Most likely trigonometry. Yeah, so most likely we're starting trigonometry. That's a big topic as well. We are most likely starting trigonometry tomorrow. Okay, so that's it for today. I'll see you again tomorrow. Allah Hafiz.